In this video, we've been asked to prove that the sum of the first n terms of a geometric series is given by Sn equals a bracket 1 minus r to the n, close brackets, all over 1 minus r. So to do this, the first thing I would do is write out what a geometric series is. So the first term is a. When you multiply that by the common ratio r, you'd get ar. When you times that by r, you're going to get ar squared. When you times that by r, you're going to get ar cubed, and so on and so on and so on. And the very last term, well, that's ar to the n minus 1. And actually, I'm just going to work backwards here as well to get the one before it. Well, if the last term is ar to the n minus 1, the term below, the power will be 1 less than it. So that's going to be ar to the n minus 2, because the power is 1 less, and so on. Okay, so that is a geometric series. I'm now going to multiply this whole thing through by r. That gives you r Sn equals, well, timesing through by r will give you ar plus, multiplying this by r would be ar squared, timesing this by r would be ar cubed, timesing this by r would be ar to the power 4, plus, and so on and so on and so on. Timesing this by r will give you ar to the n minus 1, increasing the power by 1, n minus 1, plus, timesing this by r, increase the power by 1, so it'll be ar to the n. So we have taken our geometric series and we've multiplied it through by r to get rsn. Now what we're going to do is we're going to subtract these two lines from each other, these two equations from each other. So we're going to do the top line, subtract the bottom line. So I'm just going to subtract them from each other. Okay, so let's do that. So first of all, we're going to have Sn and we're going to take away Rsn. So Sn take away Rsn. Now let's do the rest. Now we're going to subtract these from each other. Now notice here we've got an AR and we've got an AR here. So if I take my AR and I take away the AR, well, that will give you 0. So this and this will give you 0. If I have my AR squared and my AR squared, well, if I have AR squared and I take away an AR squared, well, they again will give me 0. If I've got an AR cubed and an AR cubed, again, if I subtract, I'll get 0, and so on. All the way down to, well, ar to the n minus 2, and the one here would be ar to the n minus 2, well, they would take away cancel out. And then we've got ar to the n minus 1 and ar to the n minus 1. Again, if you subtract, you'll get 0. So we're going to be left with a subtract, remember we're subtracting the bottom line, so subtract ar to the n. Now what we're going to do is we're going to factorize the left hand side and factorize the right hand side. So factorizing the left hand side will give you, well, Sn is going to come out, so Sn bracket 1 minus r. And then the right hand side, a will come out, so a bracket 1 minus r to the n. Now we're going to divide, so it's going to give you Sn equals a bracket 1 minus r to the n. And you're going to divide that by 1 minus r. And that's what we've been asked to prove. So let's just put our QED on the end just to show off. And there we go. So we have got our proof.